Okay, first of all, I'm happy that even during Corona times, we are able to speak in front of such a packed audience, hopefully online. And especially thanks to Philip, who has actually a better prediction when lockdowns will happen than Drosten of the RKI. I mean, he nailed it with the last CAC, and he nailed it with this one as well. So, what I will be talking about today is basically it's basically topped on Karsten's presentation on how the combination of certain IoT devices and in the end a identity and a blockchain enables better and more resistant processes in the industry. As always, I'm talking about the chemical industry. In this particular industry, it is important to know that these supply chains are very widespread. So for a typical chemical product, normally a tanker starts in Singapore, ships some raw materials to San Francisco, and from there, and these will only be 30% of the whole distance. So in this case, it's widespread and it's very, very complicated. And these these processes, in particular, are very, very diverse, not only where the products are shipped, but actually where the different tasks are done at a company. And this picture is a demonstration of a typical delivery process in a chemical company. And in this case, it's already partly automated. And even if I partly automate it, there are still more than 100 process steps left from an order to a single payment. And these processes spread over normally 10 to 19 departments, which means from one order to one payment, there are at least 19 people or employees involved until something can be paid. And in essence, this process also leads to delayed payments and, of course, to a very low liquidity for suppliers, because customers are not able to pay in time when they're actually not able to even see where their deliveries are, because there is no transparency. And this leads very especially to a real bottleneck economy, because I'm not really able to plan when my deliveries will arrive, if my machines will still be on stock and can operate, and if I'm facing such problems, this is a very unstable way to do business. And another huge problem is that even if I have these long processes, that actually most of them are still done manually. So when I'm starting in the cash-to-cash cycle, basically from my standard order, most of the documents transacted are partly even in paper. So I have a SAP system at a customer worth hundreds of millions of dollars, and I have a SAP system at the customer side worth hundreds of millions of dollars. But in the end, the only way they communicate is because someone presses print, puts the invoice in basically prints the invoice and sends it over to the customer. And this is how $600 million worth of software communicate. And this sounds, okay, basically very unmodern, and the chemical industry in Germany is one of the biggest industries there is. So there is a real need to do something about that. And actually, when we're not looking at this from a process point of view, but actually from the point of view of the factory worker, it's basically a truck getting filled by a silo, and the only proof that I have about this truck being filled by a silo is actually a delivery receipt that is created when a truck goes over a scale at the factory. So a truck is not able to load more than 25 tons, and a wagon with a train is not able to load more than 100 tons. This means that actually the biggest size a delivery receipt can have is the size of a truck, because if it's loaded with more than 25 tons, either the tires will break apart or the whole truck by itself. So this means for a chemical factory, which has an output of thousands and thousands of tons per day, the only size I can measure my output is actually by delivery receipts of 25 tons. And by the end of the day, I'm gathering hundreds and hundreds of these documents. And then if I look one step further and take into account my liquidity problems, because customers aren't really paying in time, an average in terms of payment are about 90 days. The only thing a bank can actually measure or a bank can actually take as a proof that a delivery has happened is this receipt of 25 tons. And this does not work because this is worth around about 70,000 euros. And I have a certain verification effort for every single one of these delivery receipts. And this means that for most of the time, the costs associated with these delivery receipts for financing or for paying are much higher than the actual value I would get out of it. So you remember the 100 process steps, and actually for every delivery receipt, these process steps have to be executed, every single one. And so you can imagine what kind of costs are associated to these kind of tasks. And so we, as AZHOS, had asked ourselves, is there some kind of workaround, especially with regards to financing? And a big opportunity would be to actually not measure the trucks going out, but actually to measure the silo that fills the truck. Because it bears more than 25 tons, and this would mean bigger financing tickets for banks. But the first time I encountered an actual chemical factory, it was not as digitized as I expected. So we approached the a manager of the department, and we asked them, okay, can you estimate how much material do you have in your warehouse right now? And he answered, okay, we have sensors to measure that, but actually these sensors are as good as they're old, so none of them did work anymore. And the last time they were calibrated was 5 years ago. So actually, the data was useless. And if I have data that is useless, all my other processes that are based on it are useless as well. So actually, what did he do? He took out his phone, he called an intern, and the intern took a bike and drove approximately 2 kilometers through the chemical warehouse. It's very big. And he climbed on top of that silo and knocked 3 times. And you can actually imagine it really like with a bottle of water. I knock at the top, middle, and at the bottom. And the sound differs depending on how much inventory is left. So actually it sounded a bit darker at the bottom. So he came back with the wonderful conclusion, there must be 1/3 left in the tank. This means 30 million euros, for example. But if I now approach a bank and ask them, I need supply chain financing, and yeah, my intern knocked 3 times, now give me 30 million euros. This doesn't work as well. Because there is literally no data quality and no data transparency financial institutions can rely on. And this is even more stressed by certain regulations like Basel III that prescribe certain risk premiums on assets that are not quantifiable and therefore not financeable. So in this case, if I have a liquid asset or a bulk asset, like it's used in the chemical industry, so an asset that is stored in a silo, this classifies as not quantifiable because I have no clear track of it, and therefore it is much more expensive for chemical companies to finance them. And together with all these other problems, long processes, expensive processes, this makes supply chain financing in this industry not viable. And this is also expressed by the total market volume. So basically, there is a potential of 20 billion of financing revenue in that sector, but actually only 2 billion are already covered by banks. So there is still a huge market open for it, but not accessible today because the industry isn't ready for it or the technology isn't able to prove what they have. So the whole thinking was, what can we do about it? And in essence, we try to find a solution where we can take the measurement level of a silo, not from an intern, but from an actual sensor, and prove with them how much material is available at a certain time, a certain place, and in a certain quality. For some materials, this is possible. And this means that we have an automated way of proving assets to banks that they can now believe in. And this is actually done by already a few companies in the space, a partner of us, Orbit Logistics. And what they're basically doing is putting normal sensors in silos that measure in real time what's in there. But this information is still not usable by banks because of the way it is stored. If I have a chemical company like BASF using a system like vendor managed inventory, like our partner Orbit does it, this means that the data from the sensors is stored in a central place. This means either the database of BASF, the database of Evonik, or any other company. But this means that also one single party has all the access to this information. And in the second step, this means that they can do everything with it that they want. And a bank cannot trust information that can be manipulated by a party at any time. So it's not really so the measurement is not really the problem, but the data integrity of the data gathered. And in this case, this is a perfect situation to apply a blockchain solution. Because I have many parties relying on the same information, so the filling level. And in this case, if we now connect these sensors or IoT devices directly to a blockchain, it is now possible to distribute the information between several partners in the supply chain. So instead of BASF saving information about BASF silos and customer silos, the information is now spread 50-50 between a customer and a supplier. And this actually enables now banks to believe the information because no party can manipulate a specific data set without the other party consenting. And in this case, this leads to a perfectly distributed data structure. And now financial institutions can believe in it because there is no real case for fraud anymore. The incentive of a customer is actually to pay less than what is prescribed. The incentive of a supplier is to charge more than he delivered, so the potential incentive for fraud. But if now both parties share 50% of the network, this leads to a situation where there is no incentive for collaboration for fraud anymore. And this now makes the information real transparent and usable. And if we can now store a specific set of data regarding every silo, this means that there is now a clear, transparent view which assets exist where, when was something consumed, how much is this worth, and this enables much more opportunities for supply chain financing than what is existing today. Because actually, it is not about uploading an invoice anymore and trying to get that invoice financed by a bank with a high-level due diligence, but actually I can connect the assets I'm measuring with the actual invoice, with the delivery receipt, and so on. So there is actually no possibility for someone to take advantage of that system. And we can also solve the problem of the process chain. Because in this case, the true information about the material is not only denoted by the delivery receipts, but actually also by the sensors. So we can check which delivery receipt relates to what level of consumption in a silo, and we can actually spread this up. So there is now a clear proof of existence for every ton of material in the warehouse. Exactly, and this enables, in the second step, not only to share the information with banks, but also to automate the process behind it. And this basically looks like this. So we can, I'm sorry, these slides are a bit faster than I am. Now it should work. Perfect. So in essence, the sensor measures the inventory level. We can directly look into a SAP system of a company to retrieve the framework contract for this kind of asset, and therefore we can actually put a price on every consumption measured by the IoT device. This price can now trigger a invoice, because basically we know what was consumed in a delivery relationship, and we can now automatically generate the invoices associated to that kind of filling level. In the third step, if there is consent between both parties, and therefore everybody agrees on the data set, we can automatically trigger a payment via a direct connection to the SAP system. This means that it's actually technologically possible to shrink down payment terms from 90 days to minutes, because now not my treasury or accounting department is responsible for paying, but actually the sensor itself is enabled to do payments for a company. This means a silo in the end is not a dumb piece of metal anymore, to put it like that, but actually a device that can order for itself if it's empty, that can actually sell its own material based on framework contracts, and in the last step actually pay for itself or retrieve financing from preset partners. And this system can run fully autonomously. So this means the whole process from ordering, from invoicing, from paying, and from financing is now completely obsolete. And the best part about the system from a basically technical perspective is that I turn silos in a specific profit center. Because when I now measure the inflow of material in a specific silo and the outflow, this is, from an accounting perspective, nothing else than a revenue or cost associated to this silo. And this means that a single silo can now be a profit center, and if it can be a profit center, it can be invested in. So basically, with this level of data transparency, it is possible to assign a ROI to a previously piece of metal that stores material. So this silo can have a specific ROI, and therefore, in the second step, it can also be tokenized, securitized, etc., depending on the prerequisites of the company. And this can work everywhere where we deal with bulk goods, with bulk materials, with liquids, oil, or gas, anywhere in that area. And maybe to mention, there are also other companies that are very much involved in this space. We are, in this case, talking about Gen 2. They basically developed an infrastructure that enables the securitization of assets autonomously. And this is a possibility for companies like us to actually connect many, many sensors or a huge part of the infrastructure and make it accessible to other investors. I think I'm pretty well on 20 minutes, so I will use the last minute to answer questions. Yeah, anyone in this, from these 20 people?
To make this a little more seamless, I actually have one. Yeah. The story with the bike and the intern always sounds unbelievable. Is that a true story?
It happened.
That happened this way.
I wouldn't tell it for if it.
Amazing, amazing. Thank you very much. Please, one round of applause for Tony Oehm.
Yeah, and if anyone wants to have another chat, I will be outside so we can talk without masks.